Today is our third lecture, and the lecture is on conventional sources of electrical energy. Now, yesterday we were talking about the transmission. I showed you a diagram for power system structure. Now, there someone asked me about HVDC. Now, HVDC can have two purposes. One is the long distance transmission, as I said, north east to south. Another important application of HVDC throughout the world is back to back connection. Now, what is back to back? All of you know France is having frequency of 60 hertz, whereas England is having 50 hertz. That is why we are also having 50 hertz. Now, these two AC systems can be only connected by HVDC, because that is called asynchronous link, and this is also called back to back connection, because you are just two neighboring AC systems you are connecting. So, this can be in the same building, in fact, that is why it is called back to back. The advantage I already told you, you can connect two systems of different frequencies. Now, the primary or feeder voltage is 11 kV in that figure, which I showed you last time, and secondary or consumer voltage will be 415 volts for 3-phase connection and 230 volt for domestic single phase. Now, we can have any consumer. You can have a domestic consumer, you can have an industrial consumer, you can have a commercial consumer, and each consumer will have its own requirement, and the electricity utility is obligated to supply the voltage of your choice. Of course, they are free to take whatever tariff they want to take. Now, system design, planning and operation, this is the main three segments of any studies. You have to design a system. Before design, obviously you have to plan a system. Having planned and designed a system, system must operate. Otherwise, what is the use of that system? Any system which is inoperative, you have definitely gone wrong somewhere, either in designing or in planning. Now, when you want to operate, what is the main objective of any system engineer or planning engineer? The operation has got to be economic. See, all said and done, you can't sort of forget about cost, whatever you do, and it has to be reliable. Now, reliability is as important as economy. What is the use of a power which is 10 paisa per unit, but any time you may have it, you may not have it. Based on such a power which is highly unreliable, may be cheap, I do not think any customer will purchase such a power. So, the power has got to be economic as well as reliable. Now, when you say economic, economic does not necessarily mean cost minimization. What is economic is minimum pollution, minimum loss. So, attributes to the economy need not be only cost. Any power generated by utility which creates less pollution is more welcome than the power which may be 10 paisa cheaper, but it creates more pollution. Okay. So, you do not, why people purchase a petrol of higher price? If you go to any petrol station, you will find two types of petrol, premium and the normal. Premium is normally a rupee or 1.5 rupee costlier per liter, but I have seen many people preferring that because your car runs efficiently and more mileage, further you create less pollution. Now, one car is not important, but sigma of cars are definitely important for pollution of a city. Loss, as you know, the loss also should be minimum. Now, when we talk of conventional sources of electric energy, as I have been repeatedly telling you, there are only 3 conventional sources in the whole world: thermal, that is coal, gas or oil, hydro, that is only water, and third is nuclear, only fission is possible, fusion is not yet possible in practice. Fusion is only a theoretician's delight. You can go on producing papers, you can go on having PhD degrees, but in reality so far we are not successful in producing power using fusion. One day, yes, why not, but how far is that day, we really do not know. Now, when you talk of thermal power station, as I said, it is steam based or gas based, and chemical energy is converted to mechanical energy, which in turn is converted to electric energy. Now, this figure which is in front of you is a schematic diagram of a coal fired steam plant. That means we use coal as a fuel. Coal has got to be pulverized first. So, there is a pulverized mill. What is the meaning of pulverization? You make coal, convert coal into a very fine particle. Why? Those of you who have done mechanical engineering courses, perhaps all of you have done, you know that if it is further fine, the calorific value is better utilized and you get better heat out of it. So, coal gets entry from here. In fact, coal handling plant and ash handling plant you might have studied in your power station practice course, where the best book is Opet and Storsky by McGraw-Hill. There are Indian books as well. Now, this coal when gets burned, there is a burner here. People have done PhDs on design of burner in Center for Energy Studies. So, how to design burner itself is a R&D topic. Now, of course, we are not going to do that here, being a master's course. Now, this burner, we get a preheated air to help better combustion, better heat value, and then this is a boiler, and the water which comes here goes as a steam. Now, what particular pressure and temperature you want of steam, that is up to a designer and a planner. Superheated steam is always better, but at a cost. Everything that you want, you have to pay for it. Now, this steam passes through a turbine. I am sure you must have read these turbines in your mechanical engineering courses. Now, this turbine converts the chemical the energy which is coming in the form of steam, and it becomes a prime mover and it runs your generator. This is a generator here. Now, what is this stack in between? This stack is a particular device which facilitates the what you call the gaseous pollutants to go out and disperse in the environment, in the atmosphere. I am sure all of you can immediately appreciate, higher the height of this stack or chimney as you call it, better it is. Why? You will get a wider area, so that it can dissipate over a larger area, wider area. So, whatever are the bad effects, ill effects of these gaseous pollutants, they are so diluted that nobody gets adversely affected to a larger extent. I will not say there will be no effect, there will always be a effect, but let that be minimum. There is some permissible value. Before we talk more about these gaseous pollutants, let me tell you about solid pollutants. What is a solid pollutant in a thermal power station? Ash. Why do you have ash? If you burn anything, naturally you are bound to get ash. Now, unfortunately, coal, the Indian coal, the quality is not good. The ash content is 40%. Now, when you have a 40% ash, naturally you can well imagine it will be deposited there. How do you collect it? By electrostatic precipitator. In some of the courses they will definitely talk in detail about electrostatic precipitators. Again, a PhD thesis is going on this topic. Professor Avinash Chandra must be teaching you in whatever course he teaches about electrostatic precipitators. If you want to have an actual look at electrostatic precipitator, please go to Badarpur power station, arrange a visit there and see for yourself how electrostatic precipitator works, how it collects ash. Having collected ash, what you want to do? You have to dispose it. Where do you dispose it? So far, most of the power plants, the ash used to be thrown in nearby river, because you need a water near every thermal power station. You be it Badarpur, be it Indraprasth, you have Yamuna close by. Now, this is no good. Throwing your dirty things in your backyard is no good, but it has been going on, and that is why the rivers have become polluted. So, now it is no longer permitted, and in fact, you utilize ash for something good. What is that? It is waste management. You use it for road filling, land filling. You must have read or seen on TV that Bombay city has some 3,000 odd sort of gaddhas or pit holes. Remember, it is a financial capital of the country. All these things can be filled with these ashes. You can form briquettes. You can do so many things using ash. So, ash handling and utilization of fly ash itself has become a very important project in our country, mission project. Now, we come back to gaseous pollutants. What are the gaseous pollutants that you have? All of you know chemistry so well. Carbon, when it burns, anything burns get oxidized. That is what we have been taught in our first course in chemistry. Now, carbon contains, when combined with oxygen, becomes CO if the combustion is not perfect. If combustion is complete, it becomes CO2. Well, nitrous oxide, when oxygen is already used in combustion, what is left is nitrogen. So, when nitrogen also combines with oxygen, it becomes NOx, oxides of nitrogen. Then sulfur. Luckily, the Indian coal sulfur content is low. Only in Assam coal there is bit of a sulfur, but there are other countries in the world where there is a high sulfur content coal. In that case, SO2 is also formed. Now, all these gases, when they come out of chimney or stack, they not only affect human health, but affect vegetation, affect buildings, and the story does not stop here. They have friendship with the water vapor, which is always present in air. I am sure you must have done that experiment in physics, where a glass of water and outside you find the drops of water, because that proves that air has water vapor. So, when you combine with water vapor in the atmosphere, the acid is formed, sulfuric acid, nitric acid, any acid is bad, and if it is formed in a larger quantity, it starts coming back to the earth, and that is called acid rain. You must have heard about acid rain, and this acid rain is very predominant in Western world. Well, India is no exception. So, how to avoid it? For that, the US has passed Clean Air Act in 1970, Clean Air Act. We also passed the act. We have no problem in passing an act in parliament. We have a democratic system, we have a parliament, and late Rajiv Gandhi, the Prime Minister of India, in 1986, he also passed a similar act called Clean Air Act. Now, main problem in our country is not passing an act, but getting it implemented. and that is a real bottleneck. So, again US has revised its acts in early 90s, so we have also revised our act in late 90s. If you really strictly adhere and follow this act, I am sure the pollution will be minimized to a large extent. After this turbine, the steam passes through the cooling tower, it can get condensed, again water is fed back to the boiler by boiler feed pump. Okay. This precipitator is also shown here, which collects the dust. Now, this steam runs, it is a prime mover, it runs your generator and power is generated. There is a circuit breaker, then there is a transformer which steps up and it goes to transmission system, which at the moment is 400 kV, as I told you, in our country. So, this is in brief the story of how power is generated by coal, oil, gas in a thermal power plant, or it is also called steam power plant, because you are generating steam. It operates at the Rankine cycle. I already talked about this, and Rankine cycle is low efficiency cycle. You must have learnt in your mechanical engineering. Higher the steam temperature, higher the pressure, more the efficiency. And if you want to still increase the efficiency, instead of non-reheat turbine, use reheat turbine. What is reheat turbine? Take out the steam from middle portion, have a reheater, bring it back again. Of course, there is a cost. No advantage can be gained without payment. So, cost of reheater, cost of these pipes, and this will increase the efficiency further. Larger the size of unit, better it is. Why? That is called economy of scale. As I told you earlier, rather having 240 watt bulb, it is better to have 100 watt bulb. It is cheaper and it gives you more or less same lumens. Cost per kilowatt decreases if you move from 100 megawatt unit to 500 megawatt unit. Similarly, cost per kilowatt hour also gets reduced when you go from 100 megawatt to 500 megawatt unit. And that is why the whole world, the practice is to go for higher size units, larger size units. They also consume less fuel, the additional advantage. It is a fuel efficient. Once it consumes less fuel, the automatic advantage is less pollution, because if you do not burn fuel, where is the question of pollution? By pollution I mean all sorts of pollution, air, thermal, waste. There cannot be anything in the world which has only advantages, nothing, no, so far nothing. So, what is a disadvantage in having a large size units? As it is, we are having shortage of power all the time, everywhere. There was a time when Kerala used to be power surplus state. Now, there is no state practically in India which is having extra power, and that is one reason why we are not going to go for national grid, barring northeast region, which I told you, that is having extra power. Because if all are beggars, who is going to give whom? So, the grid has no advantage, because nowhere, if there is no surplus power anywhere, who is going to give whom? Because everybody is in need of power. However, we definitely going to have a national grid one day, because there are certain hours in night where definitely we have a surplus power. And if you can persuade, I told you those 5 golden rules to improve your load factor and diversity factor, well, one day we will be able to use that surplus power. We were talking about a disadvantage of having larger size units. As it is, there are shortages, I told. And if one such 500 megawatt unit goes means faulted, stops working, it is a big shock to the system. Suddenly 500 megawatt is not available. You can well imagine how many industries will be derailed, how many people will not get power. And as I said, in US, if Sun Microsystem does not get a power for 1 minute, they lose $1 billion. Here, where is the question of 1 minute? For hours there are no power. And you can well imagine how much loss, national loss, how much contribution towards GDP is withdrawn, gross domestic product. But the golden rule is it should be less than 10% of system capability, system capacity. If system is of 2000 megawatt, we can afford to lose 1 unit of 200 megawatt. That is the meaning of this rule. You can't afford to lose 500 megawatt out of 2000. Now, in India, the highest size of unit is 500 megawatt, which is called super thermal unit. The first unit was imported from Germany, Siemens, and soon what is good in India is we start duplicating, start manufacturing whatever we get from overseas. That capability we have. That is why we are called second largest scientific and technological manpower after US. In fact, US also a lot of manpower is Indian and Chinese. The world, the highest size unit is 1300 megawatt. Why we are not able to go to that? Because of shock, one reason. Secondly, money. 1 megawatt needs 4 crores. So 1300 megawatt will need what? 52,000 crores. From where do you bring it? Pollution we have already talked just now before 5 minutes. Air, NOx, CO, CO2, SO2, solid ash to be collected by electrostatic precipitator. There is another mechanism or way to reduce air pollution due to thermal power station. We are not talking about air pollution due to vehicles on the road. In fact, that is the culprit number 1 or villain number 1 as far as pollution is concerned. But that is not our problem. There are other people who take care of vehicular pollution, the CNG lobby and so on. And with CNG introduction, the pollution scene is definitely looking better. We are now not that much bad as far as pollution is concerned. But let us coming back to thermal power station pollution. Minimum emission dispatch. What do you understand by minimum emission dispatch? When we do economic operation of power system, what we do? We minimize cost versus megawatt. This is the curve, cost curve, and we see that we operate at that megawatt having minimum cost. That is called economic dispatch. I talked about it while talking about load forecasting. We need load forecasting for unit commitment as well as economic dispatch. Now, instead of cost, we have tons per hour of NOx, CO, CO2. We minimize that and forget about cost. And this operation is called minimum emission dispatch. Clean Air Act I have already talked, 1970 and 90s. Quality bad, 40% ash. There is another important thing which if used will help us in reducing pollution, and that is called fluidized bed boiler. Have you heard of it? This is a special boiler design. If used, it creates less pollution. Of course, you have to pay for it. With this, we finish thermal power plant or steam power plant using coal as a fuel, because we do not have oil, we have limited gas. Cogeneration is our next subtopic of today's lecture. What is cogeneration? All of you know co-education. Two things being generated is called cogeneration. Now, here two things involved are steam and electric power. You may ask me question, in this hot country what you do with the steam? In cold countries fine, Europe, part of US, major part of US, they need steam for building heatings, commercial building, heating of commercial buildings, heating of any apartments, you use steam heating. There is a gas heating also, there is a electric heating also, whichever is cheaper people use. In India we do not need any heating, the winter is not that severe if you ignore certain pockets like Kashmir, Sikkim and hilly areas of UP, now Uttaranchal or Himachal Pradesh, and there also there is hardly anybody uses centralized heating. That is a separate thing if you have a stove or if you have a heater, or that is a separate thing. But we do need steam in industry. If you go to any textile industry, you need steam, and that steam can be generated using cogeneration principle, and you save money, your efficiency goes up. That is called using the waste heat. As I told you, waste management has become a big topic. So, waste heat generated which you are otherwise leaving in a pond, cooling tower, why not use it either for heating buildings in whatever parts it is required, Darjeeling or whatever, or use it in an industry where you need steam. Simultaneous generation of electricity and heat, that is cogeneration. If you generate them separately, that is not cogeneration. If I have a classes for girls separately, boys separately, then it is called girls college, like we have Gargi and Maitrey, Kamala Nehru and so on. There is a girls engineering college also in Delhi now, MIT, it used to be called Mahila Institute of Technology, now it is some Indira Gandhi Institute of Technology or something. So, we can always generate power and steam separately, no problem. But if you have a simultaneous generation, then that is cogeneration for industrial use or space heating. We were just talking about space heating. The efficiency becomes 65%, imagine the advantage, for 40% to 65%. Which are the industries where you need steam? Chemicals, paper, textiles, I talked about textiles couple of minutes back, food, fertilizer, petroleum refining industries. And if you have a captive power plant, what do you mean by captive power plant? The present energy bill passed in 2003 now allows you to generate your own power. Even IIT Delhi is thinking of generating its own power. We do have in fact a standby power. All the hostels now have the standby power. Now, we want to generate using gas a 25 megawatt power plant in IIT campus, so that even houses will be supplied by that power plant, and so we need not pay money to DVB or whatever generation companies they are, Tatas and BSE and so on. It is no longer DESU, it is no longer DVB, now it is private power plants. When that will happen, I do not know, but there is a planning, there is a thinking going on. AIMS is going ahead with this plan, and the power line will, the Indraprasth gas station will, the gas line will pass through IIT, the Parliament Road or Outer Ring Road as it is called, and we can also tap that gas and start generating power, still in the planning stage. So, that is called captive power plant. Now, you are a captive audience, especially in this lecture nobody can leave, that is a captive audience. So, similarly captive power plant is a power plant, you are having your own, you are the owner. So, such power plants are needed in all industries. So, why not use the steam which will also be generated along with power used in these industries, and that is called cogeneration. Now, ladies and gentlemen, cogeneration is of two types. Before we talk of those two types, let me introduce to you two important words used in power industry, used in power systems: wheeling and banking. I am sure banking all of you know. All of you must have opened your bank account after landing in this great campus. Maybe SBI or Canara Bank, you might have chosen. There is only two, not much of a choice, but two is enough. Because as someone says, privatization has only meaning if you have competition. If it is monopoly, it is worse than the government. So, we have two banks. What is wheeling? People have no much faith in the government power. So, what they have done? They have started 5-6 industries together. As I said, it is highly capital intensive industry, power industry. You need a lot of money. So, 4-5 industries together have combined and installed a power plant depending on their combined needs. So, now they can withdraw power from that power plant to the need of that particular industry, and they have forgotten about government utility. They said, no, thank you very much, we do not need any power. Hindalco, you must have heard about Hindalco, the Birla factory of aluminium. They have their own power plant, not today, since ages, Renusagar power plant, which is self-sufficient. That is called wheeling of power. What is banking of power? I have a power plant here. You may have a power plant in Gwalior, but I have an industry in Gwalior. So, I will take power from you in Gwalior and I give you power here. So, it is a banking or a barter system, whatever you call it. It is not quite barter, but it is a banking. Two possible ways of cogeneration. I was talking about cogeneration: topping cycle and bottoming cycle. What is topping and what is bottoming? When your main aim is to generate power and your secondary aim is to get steam, that is called topping cycle. You have a fuel, you use fuel to generate power, then there is a waste heat, steam, and that steam can be used for any purpose, space heating, industry or whatever. That is called topping cycle. What is bottoming cycle? Fuel, first aim is process heat. You are a textile industrialist. So, you want steam first, forget about power, power will come later. Then if there is a waste heat, you generate power using that waste heat, whatever power you can get, and that is called bonus, the extra, because otherwise you would have left the steam in the atmosphere, in the pond, in the cooling tower. So, why not use that to generate as much power as you can? Even in household, your mothers, you must have seen using last night's leftovers in making a new dish. I will not call it a waste, it is leftovers. So, you make it another dish, hot dish on that day. So, you do not have to throw that, everything is costly. As it is, it is considered bad to throw any the food articles, they are scarce. I already talked about acid rain and greenhouse effect. The greenhouse effect is raising the temperature of the earth. The earth temperature is going up and up, thanks to all these industries, thanks to power generation, thanks to so called progress we are making. You have to have a pollution if you are generating something. A person like me, if I eat something, naturally I am adding calories. Why like me? Any one of you. If you eat anything, you are naturally adding calories. You can't say I want to eat and yet I do not want to add calories. It is not possible. 0 calorie, perhaps water is the only thing which is 0 calorie. You may have a low calorie diet, you may have a diet coke or something like that, low salt something, but you are definitely going to add salt if you eat that low salt thing. Similarly, whenever you generate power, whether it is a Clean Air Act, whether it is an electrostatic precipitator, whether it is whatever equipment you have used to minimize pollution, you can minimize. CNG has not made Delhi zero pollution city, it is impossible. Moment you start your car, the pollution starts. You can't say I will, unless until it is battery, I mean electric car, which we have a Riva, which is manufactured in Bangalore. But how many people use that Riva? We do have a electricity run bus from Fatehpuri to Red Fort. In fact, Professor Rokyosamy of our IDDC is working very hard on that a bus which is run by electric power. Naturally, then there will be no pollution. But still, you can't say it will be zero, because in manufacturing those batteries, you have already created pollution elsewhere. So, do not think that solar energy also has no pollution. Those cells, they have not come from heaven. You have generated in Saibabad or somewhere CEL, and in generating them, in creating them, in manufacturing them, you have already created pollution. Only thing is that you are not creating further pollution. Gas turbines. Natural gas, methane, CH4 formula must be familiar to you, since all of you must have studied chemistry. You cannot come to engineering without studying physics, chemistry, maths. The prime movers based, PMs means not Prime Minister, prime movers based on gas turbines developed parallel to aircrafts. Imagine how much power that gas gives when you use that fuel. Gas combustion is having a higher temperature and higher pressure. Efficiency of gas turbine is roughly same as efficiency of steam turbine. Exhaust gas has heat which will produce steam, turbine and generation. We do have 6 gas turbines of 30 megawatt each in Rajghat power station. I am sure all of you must have heard about Rajghat, where there is a samadhi of our Mahatma Gandhi, the father of Indian nation. Now, this is separate gas turbines. Now, today is the era of hybrid combination. The man wants to achieve many things with one go. That is why we have a dual degree program. We have so many programs. You can get registered for 2 degrees in some universities in the world. Combined CCGT plant is what? Combined cycle gas turbine plant. What is that? Let us see. I hope you will be able to see this figure, otherwise you have to see in a book. This portion is, the gas turbine. This is generator attached to gas turbine. This is heat exchanger. The gas runs generator, but the waste heat will be utilized here to produce steam, and that steam is taken to steam turbine. And again we generate power to the generator, and both these powers are combined, fed to the grid. There is a chimney, of course, here, and there is a water, there is a cooling tower here, there is a pump here, fed back again, water goes back, forms steam, comes back, and the steam comes here again. Again you can use this steam as a cogeneration, the third dimension you can add, but I do not want to add here to make it more complicated, because the aim is to explain you combined cycle gas turbine power station. Now, we do have one 34 megawatt CCGT power station in Indraprasth power station. Again another assignment for you to go, rather than seeing Qutub Minar, Red Fort and others, you must see the Katwara Sarai load dispatch center, Badarpur power station, Indraprasth power station, Rajghat power station. This should be your Delhi tour if you want to get a glimpse, because unfortunately there is nothing called power system laboratory, because the whole world is power system laboratory. There are generators, there are transmission lines, there are distribution, there are substations. Of course, we do have a substation. You can have a look at our IIT substations. What is the importance of CCGT power plant? The fast starting. Unlike thermal power plant, which takes many hours, 2 to 6 hours to start, because even if you have put coal, even if you have burned it, it takes time for steam to generate and come to proper temperature and pressure. It takes time. The process is like that. If you want to cook a dal even in a pressure cooker, it takes minimum time. There is no magic. Put a dal, put a water, put a pressure cooker, 1 minute ready. No, not so far. Tomorrow I don't know. So certain things take time, and thermal power generation is one of those things. Well, hydropower is a quick starting one, but here we are talking about CCGT. Hydropower is our next topic on coming Tuesday. 2 to 3 minutes, whereas steam turbine takes 20 minutes to start working. 10% overloads are allowed, and so if there is a short emergency, not big emergency, then CCGT plant is very helpful. And I told you, you can always start a peaking unit if you have gone wrong in your forecast. So you have forecasted 20 megawatt and you get 25 megawatt. What do? You can't start VVPing. What do? You ask your load dispatch center fellow will ask the Indraprasth power station CCGT plant, hey, immediately start your 34 megawatt plant. If your diesel is finished, petrol is finished, you have CNG. Multi-fuel injection nowadays, cars or buses or whatever. I don't know whether you remember, there used to be a Luna long back, which you can cycle. If petrol is gone, it was so light, you can start cycling and you can reach your destination maybe more time. CO2 generation is, ladies and gentlemen, much lower here, 55%. So it is less polluting power plant. Peak demands, whenever there is a peak demand, because it is costlier and we do not have gas, mind it, we have coal for 200 years, as I said, hopefully. Delhi we have one, this I already mentioned to you, 34 megawatt power plant. What we have done today so far, we have talked about thermal power plants, and please remember, we have 72% thermal power generation in this country. So thermal power plant is very important for us. We have talked about cogeneration, especially in Gujarat. Is there anybody from Gujarat? None. Sugarcane industries, they earn more through cogeneration rather than sugarcane, because that bagasse can be used for generating power. Banking and wheeling, these two are very important concepts. Let me give you another example of wheeling. In one of the Uttaranchal village, Uttaranchal is a new state carved out of UP. Of course, it was a backward area. There were no grid, but human beings were living there. I am talking about a village where there are 25 households. Now, those 25 households also want their children to read under a lamp. They also want to watch a cable TV, the program of their choice, the news, or all those Saas Bahu serials or whatever. How to watch that? So, they got together, they had a meeting and then said, let us start a micro hydro power plant or mini hydro power plant. Why? Naturally water was flowing from a height to the bottom. So, there was a natural head, HEAD. In civil engineering you must have read in whatever hydro power plant. So, they just put a water turbine they purchased from the market whenever they must have gone to Darjeeling or Lucknow or Delhi, and they start generating power. They created their own substation, own distribution network. Each house they took, and minimum requirement: fan, a lamp, a TV and a fridge. Fridge is not that important in that Uttaranchal which is so cold, but anybody wants to have, why not? Whatever expenses come, they are hardly expenses. Fuel is free, water there is no cost, it is no coal, it is no gas, free, but still whatever expenses came they divide at the end of the month equally, because they are given equal connected load to everybody, and they are not dependent on any NGO, they are not any dependent on government. And this story was telecast on NDTV about few months back. It is a success story where you are not dependent on anybody. So, if there is any problem with your hostel or something, if you yourself solve rather than complaining to associate dean, warden, housemaster and then a dean or DD or director, it is always good. So, that is a success story of that village, Uttaranchal village. Let me tell you, they are not literate people, they have no degrees, they have never seen any university, they have never gone to any college, and yet they had enough IQ to do this. We have talked about CCGT plant. Our next lecture on coming Tuesday, same place, same time, will be on hydropower. Now, any questions please?
So, what are the disadvantages of gas-based power plant?
I told you it is costlier and we do not have gas as much as we like to have. So, it can be used only sparingly whenever there is a peaking unit required, whenever there are short emergencies, and it will be again in combination with steam, not alone. So, that it works out to be cheaper because its efficiency is higher, almost same as ST, but the pollution level is low. But unfortunately, we do not have gases, and even if we have gases, it is not only for power generation. Same story as coal. Coal is still used in some villages as a fuel. Coal is still required for shuttling services in steam locomotives. So, there are so many other uses of coal. So, we have to see, like water, why there is a fight for water. Some water is required for irrigation, some for navigation, some for power generation, some for flood control. So, we do not have enough gas.
So, costly and non-availability of
Availability and cost, these are the two main problems. Otherwise, we could have had many more gas power plants, but we do have 6 units of 30 megawatt in Rajghat power station. As and when you visit Rajghat, you can have a look at it. It is better if you go in a group and arranged visit. I think IIT can arrange a mini bus or something and you can go with your teacher. If nobody is coming, I will come with you, there is no problem. Any other question?
Same coach Rishna, how can we transmit the excess heat to the industries?
To the industry?
Yeah.
Well, you have to have a pipelines. The power plant has to be close to the industry. It can't be far off. Otherwise, you have to pay for the pipelines. And that is why we are thinking of getting a gas pipeline from Iran. And if it comes through Pakistan, it will be cheaper. If it does not come through Pakistan, it will be costlier. And similarly from Bangladesh side also. So, well, this is not the answer to your question. The answer to your question is it should be close to the industry. Normally, the owner of the industry also owns this power plant. So, he is free to have a selection of site which will suit him. Yes, please. So, I think with this we finish our today's lecture, and please do solve those problems, and see you on Tuesday. Thank you very much.